I think last time we have studied about 3-bit synchronous up counter. Okay. So today we are going to study synchronous 3-bit down counter. Okay. That we will start. First of all, I will draw a logic diagram for this counter, and then I will explain how it works. Okay. So 3-bit synchronous down counter. So it will require 3 T flip-flops. First of all, I am going to draw 3 T flip-flops. All are negative edge triggered. Okay. So this is T, now Q0, Q0 bar, T, log Q1, Q1 bar, T, log Q2, Q2 bar. Okay. So first of all, what we will do, we will connect all clocks together. So this first T is connected to logic 1. Clock signal is applied here. All clocks are connected together. And now here we are going to use AND gate. Okay. So let us connect the output of AND gate number 1 to input of AND gate number 2. Okay. The same thing we will give as input to AND gate. And again you can see this output of second AND gate that must be connected as input to AND gate, and output of AND gate must be connected as input to third flip flop. Okay, so this will provide us this is your Q0, this is Q1, and this is Q2. So this is LSP and this is MSP. So sorry. Instead of using Q0, we have to use Q0 bar. Okay. And this Q0 bar must be connected. Q0 bar must be connected to T input. Okay. And Q0 is taken as output. And here also Q1 bar must be connected to NAND gate as input. Okay. And this Q1 it may be taken out. This is Q2, Q1, and Q0. Okay. So this is the only difference between the up counter and down counter. In case of up counter, we have connected Q0 to input of second flip flop. But here we have connected Q0 bar to the input of second flip flop. Okay, and Q1 bar, Q1 bar and Q0 bar. They are connected with AND operation as an input to third flip flop. So this is what is a circuit diagram of your 3-bit or synchronous flip flop. They just use it. Okay, this is the logic diagram or circuit diagram of the flip flop, and let us see how this circuit is going to work. So first of all, let us assume the outputs to be equal to 0, 0, 0. So when all outputs are 0, 0, and when we apply a clock pulse, then what happens? That is what we are going to see here. Okay, so here you can observe previous outputs are 0, 0, and 0. Okay, now as you can see, as Q0 is 0, Q0 bar will be equal to 1. So this is 1. And again, as Q1 is equal to 0, Q1 bar will be equal to 1. So at the input of AND gate, there is 1 and 1. Therefore, 1 dot 1, it is going to produce 1. Okay. So again, you can observe here, there is a 1. At the input of second flip flop, there is 1 at the input of third flip flop, and there is 1 at the input of first flip flop also. Okay. So in this condition, when previous outputs are 0, 0, 0, the input applied to first flip flop is 1, that to second flip flop is also 1, and that to third flip flop is also 1. So as t is equal to 1, the flip flop, all flip flops will be toggled, or they will be changing the state when clock signal is applied to it. Okay, so now let us apply the clock pulse. So as we apply clock pulse here, the first flip flop will be toggled and it is going to change the state from 0 to 1. Similarly, input of second flip flop is at logic 1. Clock is applied and therefore its output will change from 0 to 1. Similarly, third flip flop, it is having input as logic 1 and therefore when clock pulse is applied, it is going to toggle and change the state from 0 to 1. So if your previous state is 0, 0, 0, then after application of the clock signal, the output will be 1, 1, 1. अरे अथर्वला इन व्हायला सांगा रे तो इन होत होता आणि बंद म्हणजे निबंध झाला त्याचा एकदम साई अथर्वला जॉईन व्हायला सांग मी इन करते त्याला पटकन सांग येतोय का अथर्व साई अथर्व येतोय का Okay, so if your previous output states are 0, 0, 0, then after application of clock pulse, you are going to obtain outputs which are 1, 1, 1. Okay, now let us see what happens. The if previous state is 1, 1, 1. Okay, so let us check out what happens in this case. So here we are going to assume the previous state is 1, 1, 1. Everything is 1. Q0 is at logic 1, Q1 is at logic 1, and Q2 will be at logic 1. Okay. So now, as all outputs are equal to 1, then what happens here? That is what we are going to see. The input of the first flip-flop is permanently tied to logic 1. So it is at logic 1. Here, as Q0 is 1, Q0 bar will be 0. So 0 will be applied. 0 will be applied as input to flip-flop number 2, and the same 0 is applied to the AND gate. Similarly, as Q1 is equal to 1, Q1 bar will be equal to 0. So both the inputs of AND gate are equal to 0. So its output will be 0. So 0 is present at the input of third flip-flop. So now what are the input conditions? The input of flip-flop number 1 is 1, flip-flop number 2 is 0, and that of flip-flop number 3 is also 0. So suppose if you are going to apply a clock pulse to such a counter, then what will happen? The flip-flop 1 will change the state. Flip-flop 2 and 3, they will not be changing the state as their inputs are at logic 0. Okay, so now let us apply the clock pulse to this and let us see what happens. The first flip-flop will toggle and it is going to change the state from 1 to 0. Okay. Similarly, here you can observe that as t equal to 0 for second flip-flop, it is not going to change the state. So its output will be equal to 1. Similarly, the input of third flip-flop is also 0 and its output is 1. So it is not going to change the output. So output of the second flip-flop will also remain the same. So now what is our new output? Our new output will be, this is MSB 110. So if your previous state is 111, then after application of the clock pulse, you are getting the state which is equal to 110. Okay. Now, for example, suppose again, if we consider the previous state as 110, and let us see what happens in this case. So our output state is 1, 1, and this is 0. So this is our previous state and we are applying the clock pulse here. As you can see, as uh, Q0 is 0, Q0 bar will be equal to 1. So this 1 will be applied here. And as you can observe, as Q1 is equal to 1, as Q1 is equal to 1, Q1 bar will be equal to 0. So what is applied at the input of third flip-flop is 0. So here in this condition, input of flip-flop number 1 is 1, flip-flop number 2 is 1, and flip-flop number 3 is 0. So flip-flop number 1 is going to change the state, flip-flop number 2 is going to change the state, but the state of the flip-flop number 3 will remain as it is. Okay, so now let us apply the clock pulse and see what happens. So first flip-flop will change the state from 0 to 1. The second flip-flop will also change the state from 1 to 0, and third flip-flop will remain in the same state which is equal to 1. So if you count it from MSB to LSB, it will be 101. So after application of clock pulse, if your previous data was 110, the next state you are going to get is 101. So in this way you can see the counting is from 111, 000 to 111, and after 111 it will be yes 110, and then it will be 101. So afterwards you will get 100 and 011 like this. You will get a down counting up to 000, and after 00 again it will go to 111. So initial state of this counter is 111, and it will down count all the states. Okay. So in this way, the counter will work. 3-bit synchronous down counter will work. Are you clear about its working? Write in the chat box quickly, yes or no. If no, ask me what you haven't understood. Just write in the chat box. Yes, students, write in the chat box whether you understood or not. Shall we move ahead for truth table and timing diagram? Shall we move ahead? Type quickly. Otherwise, we'll be wasting time. Write in the chat box. Yes, Sakshi, Sai, Atharva, Tejas. Yes, yes, yes. Write quickly, write quickly. Okay. So, let us move to the truth table and timing diagram. Let me draw both of those. So, we write the truth table. So, in truth table, we are going to write clock, stage, and output. And this output will be Q2, Q1, and Q0 in this order. So, for first clock pulse, you will get the seventh state. Okay, 111. For second clock pulse, you are getting sixth state. For third clock pulse, you are getting fifth state. For fourth clock pulse, you are getting fourth state. For fifth clock pulse, you are getting third state. For sixth, second state. For seventh, first state. And for eighth, you will be getting zeroth state. Counting from 7 to 0. Again, after 7, there will be 1. So, like this, the truth table can be written. So, similarly, let us write a timing diagram here. Always take screenshot of all these. First, we will have to draw clock pulses. One, two, three, four, 5, 6, and 7. Okay. Now let us see what happens for Q0. Let us start with the Q0. So this is your clock. Q0 will be 0 and 0. So 0, then it becomes 1. Again it will be 0. Again it will be 1. Again it will be 0. Again it will be 1. Again it will be 0. Like this. And what about Q1? It is 0, then it is 2 times 1, and again 2 times 0, 2 times 1, and 3. So this is what is your Q1. And for Q2, you can see that it is 4 times 1, and it is 4 times 0. Okay. So this is 0, 0, 0. This is 1, 1, 1, 1, 1, 0, 1 0 1 1 0 0 0 1 1 0 1 0 and 0 0 1. Thereafter there will be 0 0 0. You can extend this. Okay. So this is what is a timing diagram. Timing diagram of your counter. Okay. So take a screenshot of it, or you can draw it along with me. ओके. अथर्व धुमाळे म्हणतो रिपीट करा. लवकर लिहित जा तुम्ही. आता मी डायग्राम पुसली, पण तुमच्या ह्याच्यामधली जर डायग्राम बघितली तुम्ही, कशातली वही मधली डायग्राम लिहून घेतली असेल तर त्या डायग्राम मध्ये असं आहे की Q0 बार आणि Q0 बार हा सेकंड फ्लिप फ्लॉपचा इनपुट होणार आणि Q0 बार आणि Q1 बारची अँड ऑपरेशन ही थर्ड फ्लिप फ्लॉपचे इनपुट होणार. ओके. अशा पद्धतीने जर कनेक्शन केलं तुम्ही तर तुम्हाला काय मिळतं 0 0 0 ह्या स्टेट नंतर 1 1 1 स्टेट मिळते. स्टेट चेंज केव्हा होणार ज्यावेळेस तुमचा टी इनपुट 1 असेल. स्टेट चेंज केव्हा होणार नाही त्यावेळेस जेव्हा तुमचा टी इनपुट 0 असेल. हे कॉन्सेप्ट लक्षात ठेवा. मग प्रिव्हियस इनपुट गेस करायचं आणि मग त्याच्यावरून करंट आउटपुट किंवा नेक्स्ट आउटपुट काढायचं. प्रिव्हियस वरून नेक्स्ट काढायचं. एक क्लॉक पल्स दिल्यावर काय होतं. ओके. त्यात प्रत्येक आधी अँड गेटचं काय होतं आउटपुट ते बघायचं प्रिव्हियस नुसार आणि मग त्याच्यानंतर काय करायचं की क्लॉक फ्लिप फ्लॉप दिल्याबरोबर कोण टॉगल होतं त्यानुसार आउटपुट लिहित जायचं. ओके. ह्या प्रकारे त्या वर्किंगचं व्हेरिफिकेशन तुम्ही बघायला हरकत नाही. ठीक आहे. परवा शनिवारी सगळे होते का प्रॅक्टिकलला? तुमच्यापैकी सगळेजण होते प्रॅक्टिकलला?
नो मॅम.
नसले तरी तुम्हाला करावं लागणार आहे प्रॅक्टिकल. ते तुम्हाला कंपल्सरी आहे. जे करायला सांगितले ते कंपल्सरी आहे. त्याच्या शीट लिहून तयार करायच्या आहेत आणि ते अपलोड करायचे. ओके. आता हे दिस कंप्लीट्स युअर काउंटर. So after this we are going to study shift registers. Okay. So what we are going to study now is shift registers. Okay. हे टायमिंग डायग्रामचा शॉर्ट स्क्रीनशॉट काढून झाला असेल तर मग पुढे जाऊ आपण. पुसून टाकू का मी? पेजच नव्हता प्रॅक्टिकलला. अरे परत एकदा नाही सांगणार. तुम्ही लोक प्रेझेंट राहिले पाहिजे. मी प्रेझेंट राहिले पाहिजे आणि ते काय आहे माहिती का व्हर्च्युअल लॅब वापरूनच केलेलं आहे. त्यामुळे मागच्या वेळेस जसं केलं होतं तसं आहे. ते लिंक वापरून तुम्ही करायचा प्रयत्न करा आणि काही समजत नसेल तर विचारा आणि प्रेझेंट राहणं आवश्यक आहे. बघा सगळ्यांनी प्रेझेंट राहायचं प्रॅक्टिकलला. इम्पॉर्टंट आहे ते. त्याच्याशिवाय कसं होणार. चला आता नेक्स्ट आपल्याला जे करायचं आहे ते आहे शिफ्ट रेजिस्टर. So we'll start with the shift register. So we have already studied the flip-flops, and as you can see, flip-flop can store 1 bit of data. That means if you consider a D flip-flop, it will be storing 1 bit of data. Now suppose if you want to store multiple bits of data, then what you have to do? Then just you have to use a array of flip-flops. Okay, the number of flip-flops connected in a particular way. They are used to store multiple bits. They are called as shift registers. Okay. So shift register consists of multiple flip-flops, generally D flip-flops, multiple D flip-flops, and these multiple D flip-flops are used to store the data. They are not only going to store the data, but the data stored within them can be shifted in a particular fashion. Okay, so such type of devices, digital circuits are called as shift registers. Now these shift registers can have four modes of operations. There are four modes of operation of the shift register. The first is called as SISO, meaning of this is serial in, serial out. The second is SIPO, which is serial in, parallel out. Third is PISO, or PIPO first will write PIPO, that is parallel in, parallel out. And fourth is PISO, that is parallel in, serial out. So we are going to study these shift register modes one by one. Okay. So take a screenshot of this modes of operations of shift register, or type of shift register. You can call it as SISO, SIPO, PIPO, PISO. Okay, serial in, serial out. That means SISO. SIPO means serial in, parallel out. Parallel in, parallel out, and parallel in, serial out. Okay. Serial in, serial out means the data is inputted in serial fashion, that is one bit at a time. And serial out means data is outputted one bit at a time. So that is also in serial fashion. Now in second case, serial in, parallel out. That means data is inputted in serial way and it is outputted, taken out in a parallel way. Okay, parallel means multiple bits are taken out at a time, or multiple bits are applied at a time. That way of application or taking out of data is called as a parallel type of operation. And serial type of operation is one bit at a time. So parallel in, parallel out means all bits are inputted parallelly, multiple bits are inputted parallelly, and all these multiple bits are outputted parallelly at the same time. Okay, and parallel in, serial out means you are inputting the multiple bits simultaneously, but you are outputting these bits one by one. That is in serial fashion. So this is how the various modes of shift register they are going to work. Okay. Now let us see how to build these shift registers one by one. Okay. So let's start. For this, again, we'll be using D flip-flops and 4-bit shift registers we are going to use, and will be connection will be like this. I'm going to draw a connection with it so that you will understand. Okay. Serial in, serial out. So first configuration that we are going to study is serial in, serial out. 4-bit serial in, serial out shift register. This is what is our title. So for 4-bit shift register, we will require 4 D flip-flops. If you want to construct a diagram for 3-bit register, then you have to use 3 flip-flops. For 2-bit, you have to use 2 flip-flops. Like so, number of flip-flops they depend on the number of bits. So this has input and this has clock. So let us call it as Q3 bar here. Q2 bar, D clock, Q1 bar, D Q0 bar. Everything has a clock and these clocks are applied simultaneously to all. Okay. Now, this is what is your clock. And input is applied to the input of the MSB flip-flop. Okay, so here we are calling it as flip-flop number 3. Okay, so input is given at this flip-flop number 3 here. Output of flip-flop number 3 will be given to input of flip-flop number 2. Output of flip-flop number 2 will be given to input of flip-flop number 1. Output of flip-flop number 1 will be given to input of flip-flop number 0, and output is taken out from this QC. So this is what is your data out. Okay, so here there is data in, here there is data out. So data is inputted in a serial fashion. Data is inputted in a serial fashion, and it is outputted in also in serial fashion. Okay. So now here suppose initial state, previous state of all the flip-flops is 0. So let us consider all flip-flops having output equal to 0. Okay. And we want to apply the data 1 1 1 1 1 1 1 1 2 to the shift register, and we are going to out it in a serial fashion. We are going to in it in a serial fashion. So we are going to apply the data 1 1 1 1. So suppose if this is your MSB and this is your LSB, then first you have to apply LSB. Okay. So if your LSB here, now all bits are 1. So LSB is 1. So let us apply 1 to begin and apply the first clock pulse. Okay. So when you apply the first clock pulse, then what will happen? Output of flip-flop D, it will become 1. Output of flip-flop 2, it will remain 0. Output of this flip-flop, it will remain 0. Zeroth flip-flop will remain 0. So only the first flip-flop will have the data 1, and all remaining flip-flops, they are having data 0 0 0. Okay. So the output which is present in all the flip-flops are 1 0 0 0. So still data is not outputted here. Okay, still data is not outputted. So during the second clock pulse, what we have to apply? We have to insert one more 1. Okay, how many ones are there? 4 ones are. We are going to insert one more 1. So now in this case, you can observe input of this flip-flop number 2 is 1, and input of flip-flop number 3, it is also 1. So output of flip-flop number 3 will be 1. At the same time, output of flip-flop number 2 will also be 1. But as previous output of this flip-flop 2 was 0, so flip-flop 1 will be having 0 output. Similarly, flip-flop 0 will be having 0 output. So after application of second clock pulse, now the flip-flops will have contents like this 1 1 0 0. Now we are going to apply the third bit, and for that we had to apply the third clock. So when you do this, what will happen? 1 will be outputted at third flip-flop, 1 will be outputted at the second flip-flop, 1 will be outputted at the first flip-flop, and 0 will be outputted at the 0th flip-flop. Still our data is not outputted. Okay, so now let us apply digit, one more digit, okay, and then apply a fourth clock pulse. Then apply a fourth clock pulse. So after application of the fourth clock pulse, now what will happen? 1 is present here, and therefore output of third flip-flop will be 1, output of second flip-flop will be 1, output of first flip-flop will be 1, and that of zeroth flip-flop will also be 1. Now this 1 is outputted, or LSB is outputted. So at the end of the fourth clock pulse, the LSB is outputted. And in order to out the remaining 3 bits, you have to apply 3 more clock pulses. Okay. So after applying 3 more clock pulses, what you are getting after application of the fifth pulse, don't care about what is output of this all 3 flip flops, and output of the third flip flop, and remaining flip flops will be 1, 1, and 1. So 1 is outputted again. So during sixth clock pulse, don't care about these 2 flip flops. Okay. So again 1 is outputted. Okay. During the second seventh clock pulse, don't care about all these 3. Only fourth will be 1. So fourth will be open. So at the end of the seventh clock pulse, all data is outputted serially. All data is outputted serially. So at the output, you are getting LSB outputted at the output terminal of this. And thereafter, the next bit, and at